Hello everyone. Yes, so let us start today's topic. Are you ready? Okay, Mariam, where are others? Good afternoon. What about others? Yes, so kindly introduce yourself. हेलो, बाकी कौन कौन है बेटा? मरियम के अलावा कौन कौन ऑनलाइन है? Just write your names. Okay, Anjana. Okay, Bhavna Rathore. Okay, good afternoon. Shraddha. Okay. Okay, yes. So today, actually, on yesterday, we have a confusion about that saturated solution of NaCl. I think we have wasted around 20 minutes. But you people were right in that context. Okay. So let me tell you the fact behind that, and today we will have a thorough introduction of phase, component, and what is other thing, degree of freedom. Okay, I have made around 22 questions that we will discuss, then I will shift to the one component system, or maybe advantages of phase rule or disadvantages. Okay, so let us start. First question, today you will answer. Okay, I will just explain afterwards. Tell me, this is the equation in front of you on your screen. Yes, so tell me how many number of phases and components are present in this reaction. Which option is correct? Yes, DOF, degree of freedom. Good. Rajnikant Parmar. Okay, good afternoon. Yes, tell me, out of these four, which option is correct? Today you will answer, I will just explain afterwards. Just reply fast. Yes, beta. So this is the first question. Without wasting time, I will explain. You will write the answer in between. Okay. Say we have magnesium carbonate, magnesium oxide, and CO2. You know, magnesium carbonate is solid. Magnesium oxide is also solid. If nothing is mentioned, means they are solid. Okay. And CO2 is gas. That means, and you know, every solid has different phase. Okay, number of phases equal to number of solids present. Okay, very good, Anjana. So number of phases equal to number of different solids. Yes, number of different solids. So solids are 2 and gaseous component is 1. So total number of phases are 3. Beta, phases are 3. Say each solid has different phase. Each solid has different phase. Okay. Now number of components. So number of components is equal to number of constituents. I think I have written that number of species minus number of relations. Okay. So number of constituents are 3 and number of equations, that can be S minus R, or we can write N minus E, means number of constituents minus number of equations. So there is one equation between these 3 constituents, so 3 minus 1, that is 2. So 3 phases and 2 components. Very good. So answer should be A. Very good, Anjana. Shraddha, good. Mariam, please keep in mind what I am telling you, that components doesn't mean constituents. Okay. Components means number of independent variables, okay, which are required to specify the particular system. Okay. So only 2 components are there and phases are 3. Each solid has different phase. Okay. So this is the first question. Now come to the second question. What is the number of phases and components in this reaction? Yes. Number of phases and components in this particular reaction. Yes, tell me. In this equation. This is somewhat tricky, but I know you can do it. First of all, ammonium chloride is solid. Ammonia and HCl are gases. So gases form only one phase, solid has different phase. So number of phases are 2. One solid and other is gaseous phase. Okay. Now number of components. Two phases, very good, but justify that number of components. Say only one option is there for components, because if phases are 2, then components should be 1. So tell me, how can we justify the number of components are 1? Chemical constituents are 3. Chemical constituents are 3. So how could we justify the number of components? Anjana, right, it is 3. It's wrong, Mariam. See, first of all, there are 3 constituents, okay. So minus number of equations. So in front of you, there is only one equation, okay. But say this equilibrium is given to you, okay. This equilibrium is given to you. As it is given to you, so according to this equilibrium, nothing is mentioned, okay. So ammonia and HCl are obtained from ammonium chloride only. Ammonia and HCl are obtained from ammonium chloride only, and one equation is this and other equation is that concentration of ammonia is equal to concentration of HCl. So this is the second equation that can be generated, okay. If it is written that there is ammonium chloride, ammonia and HCl mixture of these 3, okay, then this relation is not into picture, then we should get components 2, okay. But here, as this relation is mentioned, okay, ammonium chloride to ammonia plus HCl, that means it is in equilibrium, and ammonia and HCl both are formed from ammonium chloride only. So it is -2 and number of components comes to be 1. number of components comes out to be 1. Got it? Yes, tell me any doubt in this, because this is somewhat tricky. There is one relation that is clear cut, but second relation we have to frame, because you know number of moles of ammonia is equal to number of moles of HCl, and as both are gases, so volume is equal to the volume of the container. Volume is equal to the volume of the container. That's why stoichiometric coefficients of ammonia and HCl are same. If they are not in the same phase, that is not gaseous, then situation is different. That we will discuss later on. Because ammonia and HCl both are gases, that's why components is 1 only. Got it? बेटा इस क्वेश्चन में कोई डाउट आपको? नहीं, तो आगे बढ़ते हैं फिर थर्ड क्वेश्चन. Question number 3. What is the number of phases and components in an aqueous solution of glucose? Yes. Yes, beta, tell me. Number of components and phases. First, number of phases. Okay. Number of phases, tell me. As it is aqueous solution of glucose, and you know glucose is completely, yes, very good. Very good, Anjana. Glucose is completely miscible in water, completely soluble in water. That's why it forms a one phase, right? So number of phases are 1, and number of components, there is no equation as such. There is glucose and water. Okay, that's why number of components are 2. Okay, glucose and water. So constituents is equal to number of components here. Okay, because yes, very good, because no dissociation. So 1 and 2. So D option is correct. Okay. Now, what is the number of phases and components in the following reaction? Yes, now. Very good, Mariam, Shraddha, Anjana, great. I request all of you to participate, please. Only 3 students are participating. Shraddha, Anjana and Mariam. Okay, bolo beta. First tell me phases. Number of phases. So there are 2 solid phases, 2 solids contribute 2 phases, plus 2 solids means one Fa and other is FeO, H2O gas, H2 gas. So gases means contribute 1 phase. So total number of phases are again 3. Now number of components. Number of components, Anjana beta, components, say number of constituents or species minus number of relations, or we can write number of constituents minus number of equations. So there is clear cut one equation given to you. Okay, that's why number of species or number of constituents are 4 minus 1, that is 3. So number of components are 3. 3 phases and 3 components, that means A option is correct. Okay, question number 5th on your screen. Yes. What is the number of components in a non-reactive system of KCl, NaCl, H2O? Yes, that question we have done actually, and I urged you to just subscribe my channel, okay, and like the video as well, okay. You will get many things. There are so many videos which are conceptual, you can watch anytime. Okay, so what is the number of components in a non-reactive system of KCl? Say, there is KCl, there is NaCl, there is water. Okay, so tell me number of components. System is ionic, keep in mind. Reactive के लिए 4. Okay, Abhishek, thank you. See, in KCl we have K plus and Cl negative. NaCl we have Na plus and Cl negative, and water. So number of species is equal to KCl, NaCl, K plus, Na plus, Cl negative, water. So number of species are 1, 2, 3, 4, 5, 6. Number of species are 6, and number of equations 2. Okay, wait. So say actually any ionic reaction components is equal to S minus R plus 1. So S is 6 minus 2 plus 1. Okay, so 6 minus 3 equal to 3. Okay, non-reactive here means that they cannot react with each other. Okay, because only Cl negative is there. Potassium cannot react with sodium. If it is KCl and NaBr, then but the system is ionic actually. Okay, so in ionic reactions we go like this. This is the formula used. Okay, sorry, there is no need to take like this. Okay, done. Yes. Now question number 6. Now we have reactive system. So now how many components are there? See, NaCl gives Na plus Cl negative, KBr will give K plus and Cl negative, sorry, Br negative, and now you know Na plus can react with Br negative to give NaBr, and K plus can react with Cl negative, means neutralization reaction takes place. So these neutralization steps are also counted. That is called reactive system. Now it is reactive system. In that case, there is no neutralization reaction as such. Okay. So number of species, tell me how many number of species are there? First species are NaCl, KBr, NaBr, KCl, K plus, Na plus, Cl negative, Br negative, H2O. So how many species are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of species are 9. And how many relations are there? Or we can say equations. So total equations are 4. Okay, great. Anjana, very good. Components are S minus R plus 1. So S is 9 minus 4 plus 1. So 4. Very good, very good. Very good, Mari. Okay, Anjana. Yes, there are 4 relations. Very good. Mariam, species are 9 and relations are 4. So relation component is 9 minus 4 plus 1. So it comes out to be 4. Okay. Now question number 7. What is the degree of freedom for water system? We have water system. Water system is, in water system, water can exist as ice, water can exist as water liquid, water can exist as water vapor. Okay. Good beta. Mariam, Shraddha, Anjana, very good. Keep it up. God bless you. So they say ice, water and vapor. In vapors, water system, maximum number of phases. Maximum number of phases are 3 and number of components only 1, because only water is there. Very good, very good. So degree of freedom formula is C minus P plus 2, that is the Gibbs phase rule. Number of phases, number of components. So components are 1 minus 3 plus 2. So it comes out to be 0. So D option is correct. Great. Question number 8. Calculate the degree of freedom for the following reaction. Yes, one component. Great. Shraddha, good. Anjana, very good. Yes, tell me now. Calculate the degree of freedom for the following relation. How many phases are there? 2 solids, calcium carbonate. Very good, very good, very good, beta. You people are marvelous. Great. So 2 solids and 1 gas, means phases are 3. And how many components? Components are, yes, in this case, how many components are there? Phases are 3, beta. Again, Mariam, say calcium carbonate and calcium oxide, they are solids. So they contribute 1 phase each. Okay. And CO2 gaseous. So 2 phases here, 1 phase here. Total 3 phases are there. And components, 3 components. 2 components, beta. Say constituents are 3, but there is one equation in front of you. So minus 1. Components are 2. Mariam, components are 2, phases are 3, and degree of freedom C minus P plus 2, that is 2 minus 3 plus 2. So degree of freedom comes out to be 1. Yes. Components are 2, phases are 3. So degree of freedom is 1. Which one, beta? 8th one? See, each solid phase is solid contribute one phase, because if one solid is along with other solid, then there are 2 phases. All the gases are contribute one phase. Okay, so do you have confusion in phases? कंपोनेंट्स में तो कोई कंफ्यूजन होना नहीं चाहिए, क्योंकि कंपोनेंट्स क्या है? नंबर ऑफ स्पीशीज माइनस नंबर ऑफ इक्वेशंस. सो नंबर ऑफ स्पीशीज कंस्टिट्यूएंट्स आर 3, कैल्शियम कार्बोनेट, calcium oxide and carbon dioxide 3, and equation is 1, so that is 2, components are 2. And in case of phases, each solid has different phase. अगर 2 solid होंगे तो 2 phase, 3 solid होंगे तो 3 phase, 10 solid होंगे तो 10 phase. Mariam, got it? Yes, Shraddha, very good. Degree of freedom is 1. Mariam, got my point? 2 solids contribute 2 phases and gaseous component 1 phase. If there are 10 gases, that contribute only 1 phase. Okay. Question number 9. Calculate the degree of freedom for the following reaction. Now it comes to that part which I was discussing on that day. See, NaCl in equilibrium with NaCl aqueous and H2O gas. So tell me, in this case, actually you are talking about saturated NaCl, okay, in open. I was talking about NaCl, a saturated solution of NaCl in closed vessel. Now in this case, how many phases are there? See, there is solid phase, there is liquid phase, there is gaseous phase. So there are total 3 phases. Okay. And components, obviously 2, NaCl and water. Now phases are 3, components are 2. Yes, so degree of freedom is C minus P plus 2. So C 2 minus 3 plus 2. So degree of freedom comes out to be 1. Degree of freedom comes out to be 1. Right? Let's go to next question because we have 22 questions and we are running short of time. If you have any doubt, please stop me. 10th question. Very good. Calculate the degree of freedom for an aqueous solution of glucose. Now, we have aqueous solution of glucose. So, aqueous solution of glucose, phase is 1, components 2. No need to tell you because you have already done it. Okay. So, degree of freedom is C minus P plus 2. Components 2, phase 1 plus 2. So, degree of freedom 3. Right? जल्दी जल्दी में कुछ गलत हो जाएगा तो प्लीज करेक्ट मी. वेरी गुड भावना, मरियम, श्रद्धा. Bhavna is Bhavna, your name is Bhavna only because I know the names of Anjana, Mariam, Shraddha. You are new to the system. Yes, very good, all of you. Bhavna Rathore, your name is Bhavna only or something else? Okay. So now I have 4 students, active students means Anjana, Shraddha, Mariam and Bhavna. Okay. Now question number 11. Question number 11. Yes. Calculate the degree of freedom of the following reaction. Yes. So how many phases are there? Okay. Phase is only one because gas is there. Okay. N2O4 gas, NO2 gas. Components. How many components are there? And then degree of freedom. How many components? Yes, phase 1 and components. Answer C. Wow. Component is also 1. How many components are there? I think degree of freedom is not equal to 3. Just tell me how many components are there? Two components. I think one component. Say there are N2O4 and NO2. Okay. So 2 components, 2 constituents and 1 relation. So component should be 1. Correct me if I am wrong. Say number of constituents are 2, N2O4 and NO2. But there is one relation between them. So 2 minus 1, that is components are 1. So it is 1 minus 1 plus 2. So degree of freedom should be 2. Correct me if I am wrong. Okay, say we can review these questions after the discussion as well. Okay. Okay, great. Means you are with me. Okay. Let's go to next question. Calculate the degree of freedom for a saturated solution of NaCl. Now, Anjana, you were right yesterday. Actually, when we talk of only question is saturated solution of sodium chloride. So that means NaCl solid is in equilibrium with Na plus aqueous. So phases are two, solid and aqueous, and components are also two because NaCl and water. If it is mentioned that is a closed vessel, then we count H2O gas as well. Like in the reaction, it is in the previous question, it was given that there is H2O gas, NaCl solid to NaCl aqueous plus H2O gas. Okay. If it is mentioned, then you will write phase 3, but here phases are 2. So degree of freedom now C minus P plus 2. So now degree of freedom comes out to be 2. Okay. Right. Now question number 13. Now this is the question for Mariam. Mariam, tell me how many phases are there? Nobody answer please. Only Mariam will answer. Mariam, tell me how many phases are there? If a system has 7 solid species and 2 gaseous species, how many number of phases are present in the system? Anjana, Shraddha, Bhavna, please don't reply. Mariam, tell me how many phases are there? Fast. Beta, I am waiting for your reply, please. Oh, very good, great. Great effort. There are 7 solid and 2 gases. So gaseous phase contribute 1 phase and 7 solid contribute 7 phases. So total answer should be 8. That's it. Okay, great. Now question number 14. If a system has n number of gaseous components, then what is the number of phases? Yes, anybody can answer now. Yes, we have n number of gases. Okay, then what is the number of phases? Very good, Bhavna. 1, because all gases has homogeneous mixture. Okay. Now calculate the degree of freedom for the following reaction. This is the reaction for you. Bhavna, 1 beta, 1. Gases are n, but degree of freedom is 1. Good. Because all gases form the homogeneous mixture. So there is only one phase. Solids form heterogeneous mixture. That's why each solid contribute one phase. Okay. Now tell me, calculate the degree of freedom for the following reaction. 2 KClO3 to give 2 KCl plus 3 O2. Yes. 2 KClO3 to give 2 KCl and 3 O2. First tell me how many phases are there. So there are in total 3 phases, one KClO3 solid, KCl solid and O2 gas. So 3 phases. And how many components? 3 species and 1 equation. So 2 components. So degree of freedom is C minus P plus 2. Very good beta. 3 phases. Good. And degree of freedom comes out to be 2 minus 3 plus 2, that is 1. So degree of freedom comes out to be 1. Good. Components are 2, phases are 3 and degree of freedom 1. Okay, great. Yes, this is new question for you. Very good, very good, very good all of you. Bhavna, Mariam, Shraddha, Anjana, good. Okay, what is the formula for the degree of freedom for the condensed phase rule? Say, phase rule is F equal to C minus P plus 2. Components, phases, and this, tell me, this plus 2 is for, this 2 is for, yes beta, tell me, this 2 is for what? 2 is for because you know degree of freedom means number of independent variables, okay, which we have to specify to define the system completely, and right. So this 2 is for what? Number of components minus number of phases plus 2 is for what? 2 is added for yes, but variable, which variables are this 2? Name these variables. This 2 is for temperature and pressure. See beta, variables, but variables are, this 2 is contributed for temperature and pressure. Very good, Mariam. No doubt it is for variables, but variables, this 2 specifically is for temperature and pressure, right? Now, in case of solid and liquids, two is for temperature and pressure only, Shraddha. Very good, Bhavna. So, in case of solids and liquids, you know, pressure has no role to play. Pressure has no significance. It is not significant, है ना? Because for gases it is significant. Okay. Now, for multi-component system, let us consider a 2-component system. Okay. 2 component system. That means for 2 component system, C is 2. So minimum number of phases are, for 2 component system, minimum number of phases are 1. So that means maximum number of degree of freedom, that is 2 minus 1 plus 2, that is 3. That means there are 3 variables. So that means 3D diagram we have to frame, and 3D diagrams are very difficult to draw on the page, because this page is 2D, screen is 2D in front of you. Okay, so we have to, what we do, we specify one variable, and that is what? That is pressure. Means at constant temperature, at constant pressure. So pressure is kept constant. So multi-electron system, say in case of one component system, we see the variation of pressure and temperature. But in case of multi-component systems, we keep the pressure constant, right? And we plot the graph between temperature and composition, mole fraction, generally mole fraction. Because in the next phase, we will study those phase diagrams. Okay, so in phase diagrams, when one component system is there, the graph is between temperature and pressure, pressure versus temperature. But in case it is for one component system. Okay, because when we have one component system, C is 1 and minimum number of P is 1. So maximum number of degree of freedom is C minus P plus 2, 1 minus 1 plus 2. That means maximum number of degree of freedom are 2, that is temperature and pressure. So we plot a graph between pressure and temperature. Okay, that is phase diagram for one component system. For 2 component system, what we do? We take into account temperature, okay, and composition, keeping the pressure constant. So then we apply condensed phase rule. So condensed phase rule means phase rule at constant pressure. So what we write? C minus P plus, instead of 2 we write 1, because this 2 is for temperature and pressure. Out of these 2, 1 pressure is kept constant, so that is not variable. If pressure is constant, that is not a variable. That's why only temperature is variable. Okay, so F becomes C minus P plus 1. Got it? So condensed phase rule is phase rule at constant pressure. Okay, so that means right option is B. Done. Now question number 17. Calculate the number of phases in a mixture of water and oil. Very simple question. Yes, you can answer it easily. But do like the video. Calculate the number of phases in a mixture of water and oil. Yes. Water and oil are immiscible, means they are insoluble, so they form separate phases So immiscible liquids number of phases is equal to number of immiscible. Very good beta. So answer is 2. Very good. Heterogeneous. Good. Next question on your screen. मुझे ऐसा लग रहा है कि वी आर प्लेइंग दैट कौन बनेगा करोड़पति. Calculate the number of phases in a saturated solution of NaCl and water. Say in the morning I have written all these questions on the screen so that your time, I will save your time. See how much hard work I am doing for you. So you should repay it by having strong in-depth knowledge of this chapter. Okay. Calculate the number of phases in a saturated solution of NaCl and water. Yes, very good. So number of phases are 2. Okay. But 2 phases because solution is saturated. So NaCl is in equilibrium with NaCl aqueous. Okay. So solid and aqueous phase are in equilibrium. Okay, number of phases in Mohr salt. Number of phases in Mohr salt. In Mohr salt, number of phases, and you know Mohr salt is ferrous ammonium sulfate. There are so many species, but the salt is completely soluble in water, so it forms one phase only. Okay. 20th question. Only 3 questions left. What are the factors that affect the phase rule? Yes, phase rule. You know, phase rule is affected by, yes, phase rule is affected by बोलो बेटा, phase rule is affected by बोलो. Phase rule is affected by temperature, pressure, volume, or we can say concentration. Concentrations, okay, of different constituents. Okay, so gravity or electrical force or magnetic force has no effect on the phase rule. So here concentration is given. Very good, very good. Very good, Anjana. Question number 21. Calculate the number of phases in the transformation of rhombic sulfur to monoclinic sulfur. Yes. So in rhombic sulfur to monoclinic sulfur, if they are in equilibrium, or generally we consider them in equilibrium, okay. So there is in equilibrium, both are the phases are present, rhombic sulfur as well as monoclinic sulfur, both are present. So number of phases are 2. In non-equilibrium stage, means then it should be mentioned that on complete transformation of rhombic sulfur to monoclinic, so then there is only one phase, okay, because rhombic sulfur is completely transformed into monoclinic sulfur. So in non-equilibrium stage, phases are 1, but that is not the case here, okay. So option 2 is correct. Last question for you. Calculate the number of phases in an unsaturated solution of NaCl and water. Number of phases in an unsaturated solution of NaCl and water. So obviously unsaturated solution means NaCl is completely soluble in water, means homogeneous mixture is, it is homogeneous solution. So number of phases are only 1, okay. So I think you have an in-depth knowledge of all this component, these terms of phase rule, that is number of phases, number of components, degree of freedom. Still, if you have any doubt, you may ask. Very good, Anjana, Shraddha, Mariam. Okay. Now, what are the advantages of phase rule? Advantages of phase rule. So first thing, it gives a simple method of classifying equilibrium states of system, okay. मीन्स इक्विलिब्रियम स्टेट्स जो हैं उनको एक सिंपल मेथड है क्लासीफाई करने के लिए फेज रूल से, वी कैन क्लासीफाई देम, ओके। एंड चाहे फिजिकल हो चाहे केमिकल हो, बोथ द इक्विलिब्रिया कैन बी स्टडीड बाय दिस रूल, है ना। फिजिकल इक्विलिब्रिया भी स्टडी कर सकते हैं और केमिकल भी, फिजिकल एज वेल एज केमिकल, बोथ द इक्विलिब्रिया वी कैन study by using this rule, and this rule is applicable to macroscopic systems, right? Means माइक्रोस्कोपिक सिस्टम से कोई लेना देना नहीं है फेज रूल का, है ना। इसलिए यहां पे हमने कहीं भी देखो स्ट्रक्चर की बात नहीं की, है ना, मॉलिक्यूलर स्ट्रक्चर की जरूरत नहीं है ना। यहां पे देयर इज नो नीड ऑफ मॉलिक्यूलर लेवल केमिस्ट्री, मींस मॉलिक्यूलर स्ट्रक्चर क्या है, शेप क्या है, उससे कोई लेना देना नहीं है इसका। सिंपल हमें चाहिए सॉलिड है, लिक्विड है, गैस है ना, होमोजीनियस है, हेट्रोजीनियस है ना। और ये क्या बोलता है कि ये मान लिया सिस्टम डिफरेंट्स हैं, है ना, बट देयर डिग्री ऑफ फ्रीडम इज सेम, सो दे बिहेव सिमिलरली, है ना। मीन्स वो एक दूसरे की तरह बिहेव करेंगे। मीन डिफरेंट सिस्टम हैविंग सेम डिग्री ऑफ फ्रीडम, ओके, कैन बिहेव इन लाइक मैनर, ओके। फिर फेज रूल जो है वो नेचर पे भी डिपेंड नहीं करता कि रिएक्टेंट का या प्रोडक्ट का क्या नेचर है, उससे भी कोई मतलब नहीं है उसको, है ना। आपके पास गैस जो है वो हाइड्रोजन बन रही है कि नाइट्रोजन बन रही है, दैट डजंट मैटर, है ना। तो इट इज नॉट टेकिंग इनटू अकाउंट एनी नेचर ऑफ द रिएक्टेंट्स और प्रोडक्ट, नो अकाउंट ऑफ नेचर ऑफ रिएक्टेंट एंड प्रोडक्ट, ठीक है। और ये जो प्रिडिक्ट करता है सिस्टम का बिहेवियर, वो किस पे डिपेंड करता है? इट डिपेंड्स अपॉन टेम्परेचर, प्रेशर, कॉन्सेंट्रेशन और वॉल्यूम। ये टेम्परेचर चेंज करेंगे या प्रेशर चेंज करेंगे या कॉन्सेंट्रेशन चेंज करेंगे या वॉल्यूम चेंज करेंगे, तो उसका जो सिस्टम का बिहेवियर है ना, सिस्टम का, वो भी चेंज होता जाएगा और उसको वो प्रिडिक्ट भी कर सकता है। कौन? फेज रूल। ओके, नाउ टेल मी लिमिटेशंस। व्हाट आर द लिमिटेशंस? limitations of phase rule. So first of all, you know, जो फेज रूल है वो किस पे डिपेंड करता है? 3 वेरिएबल पे, ओनली 3 वेरिएबल्स पे डिपेंड करता है, टेम्परेचर, प्रेशर एंड कॉन्सेंट्रेशन। मेन जो हैं ये 3 ही वेरिएबल हैं जिन पे फेज रूल डिपेंड करता है, ठीक है। वो जो जैसे हमने बताया अभी कि इलेक्ट्रिक या मैग्नेटिक या रेडिएशन या ग्रेविटी, उससे कोई उससे कोई फर्क नहीं पड़ता इसको, फेज रूल को। देयर इज दिस इलेक्ट्रिक फील्ड या मैग्नेटिक फील्ड या रेडिएशंस या ग्रेविटी डजंट मेक एनी डिफरेंस, ठीक है। और क्या डिसएडवांटेज है कि फेज रूल में जो है एक ही सिंगल इक्विलिब्रियम स्टेट की बात करता है वो, अगर उसके साथ कोई और भी इक्विलिब्रियम हो रहा है तो वो उसको काउंट ही नहीं करता। ओनली सिंगल इक्विलिब्रियम स्टेट जो है दैट इज स्टडीड बाय द फेज रूल एट ए टाइम। अगर कोई दूसरा भी साथ में इक्विलिब्रियम रिएक्शन पैरेलल कोई चल रहा है तो उससे उसको कोई लेना देना नहीं होगा। और मैंने बता दिया ग्रेविटेशनल फोर्स भी कंसिडर नहीं होती इसमें, ग्रेविटी की बात कर ही ली हमने, इलेक्ट्रिक फील्ड की बात कर ली, मैग्नेटिक फील्ड की बात कर ली, है ना। और ये बहुत इंपॉर्टेंट पॉइंट है कि जो इसमें लिक्विड या सॉलिड होते हैं दैट शुड नॉट बी इन फाइनली डिवाइडेड स्टेट, शुड नॉट बी इन फाइनली डिवाइडेड स्टेट। ये बहुत इंपॉर्टेंट पॉइंट है कि वो फाइनली डिवाइडेड एज फाइन पार्टिकल्स की फॉर्म में नहीं होनी चाहिए, क्योंकि उससे डेविएशन आएगी, वेपर प्रेशर चेंज हो जाएगा, सरफेस टेंशन चेंज हो जाएगी, है ना। क्लियर? नॉर्मल वैल्यू मतलब डेविएशन आएगी, नॉर्मल वैल्यूज नहीं आएंगी, है ना। तो जो लिक्विड या सॉलिड हमने लिए हैं वो फाइनली डिवाइडेड स्टेट में नहीं होना चाहिए, ठीक है। और जैसे कंडेंस्ड फेज रूल है ना, तो वो भी कंडीशंस जो हैं इसको कंसिडर नहीं करता। अगर फेज रूल आप लिख रहे हो, है ना, C-P+2, किसी को पता ही नहीं है कि 2 किसके लिए है, तो वो तो ऐसे ही लगा देगा, उसको कंडेंस्ड स्टेट में भी नहीं करेगा, है ना। कांस्टेंट प्रेशर है मान लिया तो ही शुड यूज कंडेंस्ड फेज रूल, है ना। ओके, सो दैट्स ऑल अबाउट टुडेज टॉपिक। Okay, Anjana ji, I got your point that there is a lecture at 2 o'clock. So thank you all. We will continue the lecture tomorrow with one component system. Okay. Okay, then bye bye for now.